So this is basically the demonstration of the antenna setup. So typically the measurements of any antenna will happen in an anechoic chamber, which means to say that I want to kill all the echoes. So if you just look at this particular laboratory, you will be seeing a lot of metallic pieces. What is going to happen is, once I launch the radiation which is coming from here, which is the microwave, so it is going to hit all the metallic objects in this particular room, and then it is the antenna, the receiving antenna is going to receive. So in an anechoic chamber, what is going to happen is, there are so many cones, there are pyramidal absorbers which is just going to eat away all the microwave. So this is a very simple educative or a demonstrative measurement of antenna pattern, radiation pattern. So here we have a source which is basically the same setup as we saw in the microwave ring resonator and the power divider and splitter. So this is the biasing network, the biasing box for the C-band source and the biasing box for the active detector, and from there the filter is a sinusoid. This is again a very cheap setup because we cannot afford an anechoic chamber, because an anechoic chamber is going to cost something like 1 crore rupees, and then the VNAs, the power meters, everything is again costly if we have to do the real measurement. So this is a very simple demonstrative experiment. So that is the reason why we have an amplitude modulated signal which is being transmitted using this coaxial line, which is a transmission line, from which it is connected to a microstrip patch antenna. Patch antenna was invented in 1953 by Deschamps. It is one of the most powerful antennas ever created in the history of mankind. So what is happening here is, technically speaking, we should have the antenna, receiving antenna, at beyond 2d square by lambda. So 2d square by lambda is going to tell me that the waves which is coming out of the antenna is a plane wave at that particular frequency. D will be the maximum dimension of the antenna. So once the receiver is that far, and if I launch sufficient power, I can receive my receiving signal. So once that signal is received, it is being processed, and I will be seeing a sinusoid there on my CRO. So what we have supposed to do here is, our transmitting antenna will be constant, and we try rotating the receiving antenna. So from which we are trying to compute the receiving antenna's radiation pattern. So what is happening here is, I have my transmitting antenna which is giving constant power at a particular direction, and I have my receiving antenna which is being tilted, let us say 10 degrees every side. So from which, since our reciprocity theorem works, which means a transmitting antenna and a receiving antenna are identical at that particular frequency, it behaves same whether it is a transmitter or receiver. The behavior at that particular frequency is extremely similar. So that is the reason we are trying to measure the radiation pattern of the patch antenna, microstrip patch antenna. So this patch antenna is receiving that signal, and we are trying to process. So what we do is, this is giving out, oozing out radiation, and then the receiving antenna is receiving the radiation, and we try to calculate or tabulate for every angle what exactly is the received power. So from which we create a polar plot of r theta of how much power is being received in a particular direction.
So this setup is for antenna measurements. Here you can see two tripod stand. One tripod stand is acting like a transmitter, another one is a receiver. The transmitter part, we have mounted one antenna, that is a patch antenna, and the receiver is also mounted with a patch antenna but with a rotating tripod stand. Here you have microwave source, that is a C-band 3 to 5 gigahertz source. It is passed through, the source is connected to the transmitting antenna. From the receiving antenna, the received signal is passed through the detector and then filter, and later the filter output is connected to the CRO. So initially we need to adjust phase to phase so that the maximum radiation is got. By rotating the rotating turntable, you can observe the drop in the amplitude of the signal received. That means when both the antennas are facing each to each other, we will get a maximum radiation. Then if it is slightly away from it, we will get a lesser radiation this thing. So each is rotated in steps. For each reading you need to record down what is the amplitude, of the output waveform you have received, then the gain is, once gain is calculated in dB, then the corresponding graph is plotted on the circular graph sheet to obtain a radiation pattern. From the radiation pattern, you need to mark the 3 dB line to calculate the half power beam width. The approximately directivity of the antenna is given by 4 pi by beam area. By making use of this relation, you can calculate the directivity of the antenna. Once the directivity is found, you can estimate the gain of the antenna by the efficiency factor, that is roughly around 0.65 times the D. You can calculate the gain of the antenna. The same procedure has to be repeated for two more set of planar antennas. We have one dipole antenna. The existing patch antenna should be replaced with a dipole. Later on, same set of readings has to be taken and graph is to be plotted. The third we have to replace by an Aggie antenna. Two sets, one for the transmitter and other for the receiver. The procedure to be repeated. After recording down all the readings, you need to plot the graph and calculate the directivity and the gain of the antenna.